Hey, fourth graders, it's Mrs. Seals. I'm back for our next science lab. So we started our unit on earth science, and last week we talked about some different properties of 5 different types of soil. We looked at clay, silt, sand, loam, and gravel, and we compared their color, their particle size, and their texture. Today we're going to look at another property of soil, which is called the capacity to retain water. So, capacity is a word that means the ability, and retain means to hold in. So today we're going to be looking at those same 5 types of soils to see which one retains or holds in the most water. And then we'll be talking about what this does as far as you know, being the best soil to grow plants in. Um, the soil that retains the most water is not the best soil for most types of plants because some plants could be getting too much water. And also, if a soil is very tightly packed to the point where it retains the most water, it could also mean that that particular soil is not allowing a lot of airflow through the roots. So the roots may not be getting enough air. And then the soil that retains the least amount of water may not be the best for most plants either, because then the plants wouldn't be getting enough water. So we'll talk at the end of this experiment and figure out what all this means. All right. So the way we are going to do this experiment is in each of these graduated cylinders, like this is the clay, I have added 1/4 or a quarter cup of clay. So what's going to happen is for each one of these, I'm starting with 100 milliliters of water. So I'm going to start with 100 milliliters of water. I'm going to start my timer for 2 minutes and I'm going to pour the water into the soil. When my timer goes off, I'm going to check and see how much water is in the graduated cylinder. So if I start with 100 milliliters and I subtract the amount of water that's in my graduated cylinder, that's going to tell me how much water is being retained or held or kept in the soil. Okay, so I will show you our recording sheet. And so we're looking at this table right here. It has the types of soil, has the starting amount of water, which is going to be 100 milliliters for each one, the amount in the graduated cylinder after 2 minutes, and that would mean, and then we would subtract to find the amount in the soil. All right, so we're going to start with the clay first. Now, before we do this, I would like for you to make a hypothesis. I would like for you to think, based on what you have learned in class about soil, based on your investigation and discussion in the science lab with me last week about soil, make a guess. Which one of these do you think will hold in the most water? I'm going to get my timer here ready to go. I'm going to set it for 2 minutes. All right, so we have our clay. We're starting with our 100 milliliters. I'm going to start my timer and I am starting to pour. I'm going to pour slowly because I don't want it to overflow. So you can see, hopefully. Oh, I still haven't even poured it all. Still got a little bit more in here. Got about 15 milliliters left. have about a minute left on my timer. I'm not sure if you can see. About 30 more seconds, and then we will read how much water is in the graduated cylinder. All right, there's my timer. So the 2 minutes is up. So now what I'm going to do is I'm going to look and see how much water is in my graduated cylinder. Each of these lines is 10. So there are 70, yes, 70 milliliters of water in the graduated cylinder. Okay, so let's write this down. So I started with 100 milliliters of water. After 2 minutes, there are 70 milliliters of water in the graduated cylinder. So I want to know how much water is this clay soil holding in? If I subtract 100 minus 70, I get 30 milliliters. That means this clay soil is holding in 30 milliliters of water. Does everybody understand how I got that? I started with 100 milliliters. I poured all of that 100 in. There's only 70 in here. That means there are 30 milliliters up here still being retained or held in the soil. All right, the next one we're going to do is the silt. Let me move this out of the way. I got my silt. This is the one that's like that grayish brownish color, medium-sized particles. It was kind of soft when it's wet, but it's kind of, what's the word? Slippery. No, it's kind of soft when it's dry, kind of slippery when it's wet. All right, so on my recording sheet, I'm starting with 100 milliliters of water. Let me make sure. And yes, I have 100 milliliters. So I'm going to start my timer and start pouring. It definitely did not hold in as much initially as the clay did. It's still dripping through. We got about a minute and 22 seconds left, and then I will read it. There's still, I don't know if you can see or hear, but some of it is still continuing to drip through. We got to make sure that we give all of these the same amount of time. I'll go ahead and talk. We have a minute left. If you think back to the experiment on friction, we talked about a variable. And remember, a variable is a part of an experiment that changes. You can only have one variable. We are using the same amount of each soil, the same amount of water, and we are timing them for the same amount of time. Our variable in this investigation are the different types of soils. That's my only variable, and I can only have one. If I was adding different amounts of soil or different amounts of water or checking these at different amounts of time, I don't know if my results are truly because that amount of or that soil retains the most water, or if it's because one of the other variables. This way, I know my results are truly based on the type of soil because everything else in my experiment is the same. Everything else is what we call constant. All right, we got about 7 more seconds and then I will read this. All right, that was our 2 minutes. So I'm looking, and our in our graduated cylinder, there are 75 milliliters of water. So let's think about this. I started with 100 milliliters of water. There are 75 milliliters of water in my graduated cylinder. 100 minus 75 equals 25 milliliters. So that means my silt is holding in 25 milliliters. So far our clay is holding in 30 milliliters. Our silt is holding in 25. All right, let's go to our sand. All right, hopefully you remember sand is this lightish tannish brown color. It's a rough and grainy texture. When compared to other types of soil, the particles in sand are quite large compared to clay and silt. All right, so let me get my 100 milliliters of water. That's my starting amount of water. I'm going to pour and start my timer. Ready? This is our sand. Pouring slowly so it doesn't overflow. All right, we have about a minute and 10 seconds left. And then I will check it. Gotta let it all drip through. Make sure we're doing the same amount of time for each of these. About 15 more seconds and then I will check it. All right, there's our 2 minutes. And in my graduated cylinder, I have 80 milliliters. So I started with 100. In my graduated cylinder after 2 minutes, I have 80. 100 minus 80 is 20. So that means my sand is holding in 20 milliliters. So far we have clay holding in the most at 30 milliliters, then silt holding in 25, and sand holding in 20. Next is our loam. Remember, loam is the one that is a dark brown color, which means it has a lot of humus, which hopefully you remember is that decayed plant and animal matter, which makes for very healthy, rich soil. So let's get started. We have 100 milliliters of water that we are starting with. Let me get my timer ready. All right. And ready, set, go. Huh. Very interesting. We have about 50 more seconds. Can you see? All right, so my 2 minutes is up. I am reading my graduated cylinder, and this is crazy. It is right between the 90 milliliters and the 100 milliliters. So we're going to go with 95 milliliters. So that means I started with 100. There are 95 milliliters of water in the graduated cylinder. That means that there are only 5 milliliters of water in the loam, which is very interesting. That means the sand holds in more water than the loam. All right, we'll talk about this in just a minute. We have one more, which is gravel. The gravel is the one with the largest particles. These are, just the tiny rocks. So let me get my graduated cylinder, my timer, and start. About a minute and 20 seconds left, letting it finish kind of dripping through. Wow. About 25 more seconds. All right. So when I read my graduated cylinder now, 100 milliliters of water are in the graduated cylinder. Whoa. So let's think about this. I started with 100 milliliters. There are 100 milliliters in the graduated cylinder after 2 minutes. that means the gravel is, oh, I got my hair caught. The gravel is not holding in any water. There are 0 milliliters of water in the gravel because 100 minus 100 equals 0. Now it is time for our conclusion or to discuss our results. The bottom says, list these in order from the soil that retained the most water to the soil that retained the least water. So the soil that retained the most water was the clay. It retained 30 milliliters. So I'm going to write clay. The one that retained the second most amount of water was the silt. It retained 25 milliliters of water. Then we had the sand with 20 milliliters of water. Then we had the loam, and then we had the gravel. So let's talk about what this means and maybe some things that have affected our experiment. So clay retains the most water, and that makes sense, right? We talked about last week how the particles of clay are very, very tiny. It's almost like a dust. And when clay gets wet, it's very thick and sticky, and you can mold it and make things out of it, like bowls and plates and pottery. And some people even make homes out of it. So the particles become so tightly packed that it holds in water. Clay soil is not the best for most plants because since it holds in so much water and it's so thick and sticky, a lot of airflow cannot get through. So most plants cannot survive with just clay soil. There are some that have adapted to be able to live in clay soil, but for the most part, clay soil provides too much water for the plants and not enough air. Okay. So let's talk about silt. I told you that silt is found near rivers and creeks and things like that. Silt has a lot of humus. Silt, out of the three, clay, sand, and silt, silt is the best for growing plants. However, the very best for growing plants is loam. Loam is a combination of clay, sand, and silt, and it also has lots of humus in it. That's why it has that dark brownish black color. So what this means is that our loam held in 5 milliliters of water, which for most plants is just the right amount of water. It's not too much so that they drown. It's not too little so that they don't get enough water. And because the particles are kind of spread out more and not so tightly packed, it allows plenty of airflow. So the only thing that shocks me about these results is I would have expected the loam to hold in more than the sand. I would expect the loam and sand to be switched. Typically, sand does not hold in on that much water, which is why, only certain plants can survive in the desert. So that's the only thing I would have thought would be different. I thought it would be clay, silt, loam, sand, and then gravel. Some things that could have affected our investigation, it could have been the type of loam that I used. Because remember last week I told you that loam is a mixture of clay, sand, and silt. So, and there are different types of loam. Some types of loams are more heavy with clay. Some types of loam are more heavy with silt. Some are more heavy with sand. So it could have been this particular combination that allowed for these results. And maybe if I would have used one that was more heavy with clay or silt, I would have gotten a loam that retained more water. Anyways, I hope that you enjoyed that investigation and learning about soil and their capacity to retain water. I will see you guys next time. Have a great day.